Good to see you all. My name is Balakumaran, who is going to present you a GATE video for the scheme for preparing of SC/ST students uh, for the higher study education GATE. I am from Erode Sengunthar Engineering College, and this is an AICTE Prerana. Yeah, this topic is about the heat transfer. And my name is Balakumaran. I'm Assistant Professor for Mechanical, Erode Sengunthar Engineering College, Tamil Nadu. And again, saying this video is for the GATE students, those who are preparing for the higher education. Today's topic, I'm going to handle heat transfer. In heat transfer, there are many topics. In that, I'm going to handle you two topics today, which is so easy and which can be grab a mark in a 1 minute. Yes, the topic is LMTD and NTU methods. This is syllabus. Heat exchanger would come for mechanical, chemical, production. All the students those who are studying this subject, you will have a core paper like this in your GATE syllabus, so that this will be useful for all of you guys. So that now, before going to topic, this is a topic known as LMTD and NTU methods. Okay, in that before going to topic, you should know about heat exchanger, and then heat exchanger, and then we have to know about the number of transfer units, which means NTU, and another one which is known as an LMTD, which is a log mean temperature difference. Okay, which is logarithmic mean temperature difference, which is short termly known as log mean temperature difference. Okay, fine. Before going to that, we should know what is known as heat exchanger, right? Heat exchanger, if we know only about if we come to know about heat exchanger only, we can able to know, we can able to use the formulas and substitute the answers and find out the values for NTU methods and LMTD methods. Yes, we can come into the topic called as heat exchanger. Heat exchanger, the name itself describes that heat is exchanged or heat transferred, whatever it may be. Heat is exchanged to something, for means always the heat will be transferred from the higher medium to the lower medium. Got it? From the higher medium to the lower medium. That means from heat to cooled, heat fluid to cool fluid. So that the heat would be always transferred from the heatest particles to the coolest particles. So the diagram in this has been shown you the straight tube heat exchanger is one type of a heat exchanger. In that we will pass the hot liquid or hot fluid to from one side, and in between we will have an cold fluid. The cold fluid will be separated with the help of an sheet metals or something, tubes, whatever it may be. It will be separated. It will be separated. So it will be separated, and while the hot fluid passes through the tube and the cold fluid will be touches the hot fluid, what happens? That hot fluid will release its heat, and the cold fluid will absorb the heat. Okay, this is known as heat exchanger. There are many types of heat exchanger, which is named as natural types of heat exchanging process. Then relative direction of fluid motions, design and constructional features, and physical states of fluids. Okay, under that we'll have many types of heat exchangers, like cooling tower is one of the best heat exchanger. Okay, regenerator is one type of best heat exchanger. IC engine is a heat exchanger, type of heat exchanger. Gas turbines, we use many types of heat exchangers in also in automobiles, like radiators, economizers, etc. we'll use in this. Heat exchanger is good topic. If you learn this topic, means you can able to score marks which is allocated for this topic. Okay. Okay, coming to the topic, NTU methods. NTU stands for number of transfer units. NTU stands for number of transfer units, which is used to calculate the rate of heat transfer in heat exchanger. Okay, I told about you the heat exchanger. What is heat exchanger? Heat exchanger is nothing but transferring of heat from one substance to another substance. The heat transfer will happen from the higher temperature to the lower temperature. The higher temperature, if it is 100 degrees Celsius, and I have two substances, one is 100 degrees Celsius and one is 20 degrees Celsius. From where to where the heat transfer? The heat transfer from 100 to 20 degrees Celsius. So that higher temperature to lower temperature. Okay. So the NTU method is nothing but number of transfer units. You have been studied that. I'm just refreshing the topic. Okay. NTU is nothing but number of transfer units is used to calculate the rate of heat transfer in heat exchanger, especially counter current exchangers, we use this type of NTU methods. Okay, where we won't get enough sufficient information to do LMTD method. LMTD is nothing but log mean temperature difference. Okay, yeah. Formula, before going to formula, we will come to see about log mean temperature difference. The logarithmic mean temperature difference is used to determine the temperature driving force from the heat exchanger in flow system, most notably in heat exchanger. The same thing, if you don't have many data, we will use NTU methods. We have data, we come for LMTD method. Okay, in LMTD method, logarithmic average will be takes place between the hot and cold feeds. That means nothing but hot liquid and cold fluids. Okay, yeah, 1 minute. Then now coming to the NTU method formula. NTU method formula. Okay, NTU method is a general formula which is in the red color. The red color formula is called as NTU is equal to U by A by C minimum, which can be written as del T minimum by del T LM. Okay, that is T minimum, C minimum. Okay, yeah. LMTD method formula is simple: del T1 minus del T2 divided by ln bracket open del T1 by del T2. Del is nothing but the difference. Del is nothing but the difference. Okay. Yeah. Whereas T1 is the hot temperature, T2 is the cold temperature. T1 is the hot temperature and T2 is the cold temperature, and del is the change. Del is the change. A is the area and U is the overall heat transfer coefficient, which comes in watt by meter square Kelvin. Area comes in meter square, and LMTD is a change. That will be in degree Celsius, whatever it may be. Okay. The del Tm is a formula is there. That is nothing but T1 minus T2. I will write up here. Yeah. I will write up here del T yeah, this is for this I'm saying, okay. For this I'm saying del T del Tm, which is equal to T1 minus T2 bracket close minus T2 minus small t2. Okay, capital T2, this is capital T2, this is small t2. Okay, bracket close, yeah, divided by ln, you know that, right? Ln of capital T1 minus small t1 divided by capital T2 minus small t2. If we apply this formula, we will get the value of del Tm. U is nothing but what I said. U is nothing but overall heat transfer. A is nothing but area, and del T we have the formula. In the question, if they give you the temperature difference T1 and T2, we can able to find out the value of the Q. The Q is nothing but heat transfer. If they ask to find out the heat transfer, just applying the values and find out the values, very simple, right? Okay. Then NTU simple formula is UA by C minimum. UA by C minimum. Okay. Okay. Then we are going to see about the LMTD methods formula. Okay. LMTD method formula is a simple del T1 minus del T2 divided by ln del T1 by del T2. Okay. Yeah. Okay. In that, again, we have another formula which is known as Q is equal to U A del T M bracket close. Okay, which is to find the formula for heat transfer, which is find to formula for heat transfer. Okay, so the del Tm, the same logarithmic mean formula in which we use the temperature difference. Okay, logarithmic mean formula is the temperature difference. So that the formula is del Tm. Okay, del Tm. Okay, okay. This is two formula. Simple formula. We know the formula of Q is equal to UA del T, and we know the formula of U is equal to QA del T. Both are same. Whereas the NTU method is UA by C minimum, and whereas LMTD formula is del A T1 minus del A T2 by Ln del A1 minus by del A2. Okay. Okay. If you want to time to write the formula, you can take time for writing the formula. Capital T1 is for the hot temperature, and capital small t1 is for the cold temperature. You should remember that. Okay. Capital T1 for hot and small t1 is for cold. 1 and 2 means inlet and outlet. 1 come for inlet and 2 go for outlet. Okay. Okay. You don't think that in a huge way to find out the answer it will be so difficult for us to find out the answer, and all you don't want to think out it. The finding out the answer will be so simple. Only 2 step or 3 step formula will be there, and you can apply it and find out the answer for this. Okay. Okay. Yeah. Yeah. Right now we are in the question called first question, which came in the GATE 2017, which will be 1 mark question, and the question will be like this: the saturation steam at 100 degrees Celsius condensed on the outside of a tube. Cold fluid enters the tube at 20 degrees Celsius and exits at 50 degrees Celsius. The value of the log mean temperature difference LMTD is dash degree Celsius. So you know the question again. I will know again written in a fast way. Saturated steam at 100 degrees Celsius consider condensed on the outside of this tube. Cold fluid enters the tube at 20 degrees Celsius and exits 50 degrees Celsius. The value of the LMTD is dash degree Celsius. This is actually a 1 mark question, which is not a multiple choice. You should calculate the formula and you should find out the answer for this. Okay. Yes, I'll give you a solution for this. You try it out. You can see, check it out the best way to do it out. Okay, I'll give you the answer for this. Yeah, this is the answer actually. This answer for this answer is nothing but just write down the LMTD formula first. Okay, LMTD formula first. Okay, the LMTD formula is nothing but 1 minute. Yeah, nothing but not this one. Yeah, right here. Same T1, capital T1 minus T2 minus T2 minus T1 divided by Ln bracket open capital T1 minus T2 divided by T2 minus small t1. Okay, I think so it is clear actually. T2 minus T1 bracket close. Yeah, this bracket also close. Capital T1 minus small t2 minus T2 minus T1 bracket close ln of T1 minus T2 divided by T2 minus T1. Yeah, if you take the value of this, take this value 100 degrees Celsius, 20 degrees Celsius and 50 degrees Celsius. Okay, 100 degrees Celsius, 20 degrees Celsius and 50 degrees Celsius. What I said, the capital T1, T1 stands for capital T1, T2 stands for hot fluid, and a small T1, T2 stands for cold fluid. Here, capital T1 and T2 are same, that is 100 degrees Celsius, and small T1, T2 is 20 and T1 is 20 and T2 is 50 degrees Celsius. Just apply it, we will find out the value for this. Just apply it and you will find out the value for this. Yeah, the answer will be answer is 63.5 to 64 degrees Celsius. The answer will be 63. Yeah, 1 minute. Simple. Just you want to know about the LMTD formula, T1 minus T2 minus T2 minus T1 divided by L and T1 minus T2 divided by T2 minus T1. If you apply all the values in the respective boxes, and if you get the answer will be like this, it will be around this one. You can write it as approximately is equal to 64 degrees Celsius or 63.2, 63.5 degrees Celsius, because this is a one mark, we just fill in the blank. So there will not be open choice. So you can't able to select the option. You should give the answer for this. Okay. Now this is clear, right? Simple. It's one mark question. You can apply within a fraction of seconds, or you can take a 1 minute to just because initial stage will take 1 minute. After that, if you see that result, you can able to find out the answer. Okay. Yes. We go for the next question. Next question is okay. It's also asked in GATE 2017. It's also a one mark question, which is a question which comes in the heat exchanger same topic. In this, I'm going to read the question. The question is, in a counterflow heat exchanger, water is heated at a rate of 1.5 kilogram by seconds from 40 degrees Celsius to 80 degrees Celsius by an oil entering at a 120 degrees Celsius and leaving at a 60 degrees Celsius. The specific heat of the water and oil are 4.2 kilojoule per kilogram Kelvin and are 2 kilojoule per kilogram Kelvin respectively. The overall heat transfer coefficient is 400 watt per meter square Kelvin. The required heat transfer surface area in meter square is, okay, what they asked to find? They asked to find area in meter square. Okay, okay. Overall heat transfer is nothing but U. U is 400 watt by meter square Kelvin. It is square actually, square. And they have been given you some rate of water heat at a rate of, that means mass, and they have been given you two temperatures by an oil entering at 120 degrees Celsius and leaving at 60 degrees Celsius. So that there are four temperatures. One is 40 degrees Celsius, and one is 80 degrees Celsius, and one is 120 degrees Celsius, and another one is 60 degrees Celsius. And they also given another mass. This mass comes for hot, that is M H, and this mass comes for M C. Okay, this is and the specific heat of the water. This is sorry, this is mass. Not this one is not mass. This is specific heat. That means Cp and Ch. Okay, Cp and Ch or Cc and Ch. You can give it as you what the way you are studying. And heat transfer area they have been asked you. So that for this we are going to find out the formula first. What is the formula actually? Q is equal to U A del T M. Okay, U A del T M. U, what is the U? U is 400 watt by meter square Kelvin. We have to find out the area. If you want to find out the area, we should know about Q and we should know about del Tm. If we know only these two values only, we can able to find out the value of area. So that the Q formula, everyone knows this another Q formula which is known as MECH-GATE bracket open capital T1 minus T2. Okay. Okay. Now say me which is T1, capital T1 and capital T2. Why we are not using another formula? There is another formula which is known as MC CPC cap small T2 minus small T1. Okay, but we are not using this formula because we don't have MC value. So we are not using this formula. We are using only the formula which is known as MHCPH T1 minus T2 because we have specific heat of oil, we have specific mass of oil, and then we have two things which is known as temperature T1 minus T2. If you apply that you will get the Q value. Okay, we apply that, we will get the Q value. What is del Tm? As we see in the previous one, this is del Tm formula. T1 minus T2, small t, capital T1 minus small t2 minus bracket open capital T2 minus small t1 divided by ln of T1 minus T2 divided by capital T2 minus small t1. This is the del Tm. Okay. If we know Q and if we know del Tm, if we apply all these three values, we can able to find out the area. Okay, I'll give the solution here. You can check it out, but this is steps. You should know this kind of data to find out the value in meter square. Yeah. See here, the highest temperature is 120 and it reduced to 80 degrees Celsius. That means it's water. This is oil. From 120 it came to 60, from 80 it came to 40. You can take it as like this. Yes, from here to here this arrow mark and here to here this arrow mark. So which is T1, capital T1, this is capital T1 and this is capital T2 and this is small t1 and this is small t2. Okay. Fine. Yes, we came to know about the temperature. I said the LMTD formula, del Tm formula is nothing but the temp. Yeah, if you can take, you can write like this. Minus, if you do minus here itself, I'm going to apply here. If not, we can do like this. If you do this, 120 minus 80. Yeah, this two 120 minus 80 and 60 minus 40. If you apply this here, it will be 20 and here it will be 40. Okay. Directly take and apply the value here. 40 minus 20 divided by ln of 40 by 20. The value is 28 degrees Celsius, which is known as del Tm. Del Tm. Okay. And taking the del Tm and apply here. Sorry, not here. Here we have to apply. If you want to apply, we should know about the Q value. To know the Q value, we have the value called MC, CPC, TCE minus TCI. There's nothing but the same formula. Sorry, we don't use this formula because here they given you water. Water is nothing but MC. MH is not there. Sorry. Okay. MC. CPC T1 minus T2. Yes. So here it will come like small t2 and small t1. Got it? Small t2 and small t1. Small t2 value is 80 minus 40 into CPC value is here, which is 4.2 kilojoule kilogram Kelvin. Okay, kilojoule kilogram Kelvin into mass, where it is 1.5. So the final value will be, we will get the value of Q, right? We will get the value of Q. If you take and apply this Q and we are taking and apply the value of del Tm, we will get the value of area in terms of meter square. What is the value? 21.83, which is the option is D. Which option is D? Okay, wait, I will, yeah, wait. Hmm. Yeah, I will say you again. This is easy actually. Okay, this easy way to find. First, what they asked to find us? They asked to find us the area. They asked to find us the area. They have been given us 4 temperature 40, 80, 120 and 60. They have been given you 2 specific heats, CPH and CPC. Okay, and they have been given you one mass, which is water mass, that is nothing but MC, and they have been given you uh, 4 temperature, which is capital T1, capital T2 and small t1 and small t2. Okay, and they have been given you MC and MH. Sorry, not this one. MC, and they have given you CPC and CPH. Okay, so as I said previous, we should know 3 formulas. One is Q formula we should know, and we should know del T M formula, and we should know the we have been given got this U, right? Yeah, we should know Q formula, we should know del T M formula, and there are for Q we have 2 formulas. One, what is the first formula? First formula is U A del T M, and another formula is M C C P C T2 minus T1. Okay, M C T P C T2 minus T1. If we apply that, what happens? We get Q, and after applying that del Tm, we get del Tm value. Apply that, we will get finally the A value, which is 21.83 meter square. Okay, yeah, note down this question. Yeah, yeah, this question which was asked in GATE 2016. I read out the question here. Consider a parallel flow heat exchanger with area AP and a counter flow heat exchanger with area AC. Parallel flow we have AP, which is area, and parallel is AP, and counter flow area A and counter is CAC. In both the heat exchanger, the heat stream flows at 1 kilogram meter square cooling from 80 degrees Celsius to 650 degrees Celsius. For the cold stream in both the heat exchanger, the flow rate and the inlet temperature is are 2 kilogram per meter square and at 10 degrees Celsius. This means inlet temperature is 10 degrees Celsius and the heat exchanger cold stream. Okay, heat exchanger for hot stream is 1 and cold stream is 2. The heat and stream in both. Okay, heat and 1 minute. Yeah. The heat and the cold stream in the both the heat exchanger are the same fluid. Also, both the heat exchanger have the same overall heat transfer coefficient, that means constant. Both same have in the both the overall heat transfer, which is known as U, which is constant. The ratio of AC by AP is, they are asking you to find out the value for AC by AP. Okay, area of the parallel flow and to the area of the counter flow to the area of the parallel flow. Okay, first note of the all the points what they given. AP AC we have to find, and they have been given a hot stream and cold stream with 2 different masses and the three temperatures, and they asked to find out the ratio where the overall heat transfer coefficient is constant. Okay, both the heat transfer having same overall heat transfer coefficient. Shall we go for the answer here? Yes, this is the answer. Yeah, the answer like this. What is nothing but they have been given you to find AC by AP. Okay, AC by AP, which is what they said. They said that this U and this U are common. We can go from back. Okay, this U and this U is common. So that we to find AC by AP means it goes like it cross multiply, right? AC by AP. So that AP by MP by MC will be the answer. We need to find out the answer. To find out this answer, we should know what we should know what is this. Okay, we should know what is this. This is nothing but del T actually. Del T M. You know the formula, right? U A del T M. For hot, we can keep it as H. For cold, we can see P as C. Okay, both are common. So that U and U will be cancelled. Area for H and that means parallel flow, we can keep it as actually parallel flow and counter flow. So that can be P, it can be C. Okay, del T M. Okay, del T M. So that we should find out the value for this two del T. Two del T's. If you have find out the value, you can come out with the final answer. Okay, they have been given you three temperatures, right? One is 80, 50 and 10 degrees Celsius. 80 here, 80 is here and 50 is here and 10 is here. Okay, were they given you another temperatures here? Okay, there's no temperature, right? Okay, yeah, then another temperature is uh, the thing is like 10 degrees Celsius, right? Three temperatures. Okay, yeah, 50 is half is 25, so that is here. So that this minus this is 70 degrees Celsius and this minus this is 25 degrees Celsius. Take this 25, apply here. So 80 minus 25 is 55 degrees Celsius and 50 minus 10 is 40 degrees Celsius. So that just taking that the final value is 70 minus 25, 55 minus 40 divided by ln of 70 by 23, not 25, right? 25 and 50 minus 40 divided by ln of 55 by 55 by okay 55 by 40. So that answer will be like this. Approximately the value will be 43.705 and 47.015. Which you take and apply here, the value will be 0.927 approximately. Approximately the value will be 0.927. So this is a fill in the blanks now. So that you should do this. Okay. First two things, they have, if there's a ratio, that means two things will be equal, and for the equal components we should cancel the unwanted things. U and U cancel, and we apply this value here. We will get the value as AC by AP is equal to that means del Tm divided by del Tm of parallel flow divided by del Tm of counter flow. Just del Tm, we have to find the del Tm. For that we should know the temperatures. We apply the temperature and find out the answer. So the final answer will be 0.927. Got it? Okay, fine. Yeah, the next question, which is an just a question and answer session. Actually, this is not actually problematic, but for this also they have been awarded 1 mark, for which is easy to get. These questions will be like this, which has been 2016 for the heat exchanger. A del T max is the maximum temperature difference, and del T minimum is the minimum difference. Okay, you don't want to take this one actually. You can separate this. This is not needed actually. Both are same. Okay, what they're saying is del Tm is nothing but maximum temperature and del T minimum is nothing but minimum temperature difference. Okay, del is nothing but difference. Okay, LMTD is nothing but log mean difference. Okay, C minimum and C maximum or minimum and maximum heat capacity. Okay, CP, we are saying that that's a minimum specific heat, CP is specific heat, C C minimum and C maximum or maximum minimum and maximum heat capacity rate. The maximum possible heat transfer Q max. They ask you to find out the Q max between the two fluids. We have to say the final answer for this. Okay, final answer for this. The answer is the temperature difference in temperature difference in sir, yes, not for a given fluid, but across a fluid and maximum heat transfer occurs for C minimum and the temperature difference is equal to THI minus TCI, which means higher temperature minus lower temperature. Okay, C minimum and temperature difference, which is known as this one. This is your answer. Okay, this is the answer. Okay, okay. Yeah. The next question is also fill in the blanks. A double pipe counterflow heat exchanger transfers heat between two water streams. Tube side water at 19 liter heated from 100 degree to 38 degrees. So lower temperature on 10 it's a 10 degree Celsius to 38 degree Celsius. Shell side water at 25 degree Celsius entering at 46 degree Celsius. Assume constant property of water density is 1000 kilogram by meter square and specific heat is 4186 joule by kg Kelvin. The LMTD in degree Celsius. Now to see, they have been asked you to find LMTD. LMTD formula is, as usual I said before, the LMTD formula is simple formula. The formula is del Tm is equal to the formula. That formula is simple formula which is known as capital T1 minus small t2 minus capital T2 minus small t1 divided by ln of T1 minus T2 divided by T2 minus T1. They have been given you water density. Okay, they have given you three temperatures. Okay, okay. Let me go for the answer for the solution question. The question answer is this. I said the formula is here. To know this, we should know about the two temperatures. Here they have given you one temperature, that is 46 they have been given you, but we should find the 38 and this constants and all we have to find out. So finding out, we are using this formula rho. They have given you answer like rho and they have been given you specific heat capacity. Okay, the general formula MC is equal to C TC naught minus TCI, which is equal to C for which will come for which will be coming for H. Okay, just we apply that, we will get the two answers. One is so okay, we have this answers, right? We have yeah, we have three answers, right? 10 degree Celsius, 38 degree Celsius, and 46 degree Celsius. So we have to find only one temperature, which is this temperature. If we find out this temperature by equaling this two, and we get this temperature as 24.72 degrees Celsius. You can take and apply in that LMTD. We will get the value as level 0.0206 degrees Celsius. This is the answer. Okay. All the things will comes under single formula, that is LMTD formula and NTU formula. If you know the simple formula, you can just apply and find out the answer. Okay. Okay, fine. Okay, the next question. This is also easy question. You just by doing it, so we can able to understand saturation vapor in condenser to saturation liquid in condenser. The heat ratio we see as could see minimum. Okay, the effectiveness E of the condenser is saturated vapor in the condenser to the saturated liquid. The heat capacity ratio is CR is equal to C minimum, C maximum. The effectiveness E is of the condenser is. They ask to find out the E formula. This is actually a formula. This is a general formula. We know that this is the formula actually. D is the formula. 1 minus EXP bracket open minus NTU. This is the general formula. So we should know that. Okay. Okay. Yeah. Yes. The next question is asked in 2014. The next question which has been asked in 2014. I read of the question here. Do I am going very fast? I think so. But these are simple things which have been known for all, so that we can revise the questions and we can come to know about the answers here. Okay, so don't take it as an because this is an easy topic actually. Heat exchanger, it is a vast topic actually. In that we can come with an easy topics to go to good marks at this part times. Okay, so uh, in a heat exchanger, it is observed that del A1 is equal to del A2, okay, where del T1 is equal to del T2, where del T1 is the temperature difference between the two single phase fuel steam at one end, and del T2 is the temperature difference at the other end. The heat exchanger is, they ask you to find out the answer. They given you this thing. In an heat exchanger, it is observed that both temperatures are equal, difference are equal, where del T1 is this and del T2 is this. They are asking what is the answer for this. Actually, this 2 won't come, I think so. Okay, this 2 won't come, I think so. Okay, yeah, the answer is third one. Yeah, the answer is third one. Yeah, the answer is third one. These two are wrong because by seeing this we know that they have been asked about the heat exchanges, right? This is a good exchanger which is known as parallel flow heat exchanger and counter flow heat exchanger. They said that the both heat exchanger difference are same, which comes in counter flow heat exchanger. Okay, this is the answer. This is simple. You can by seeing it, we can able to say this answer for this. Okay, the next question which I asked in 2012. I read the question here. The water which has Cp value at 80 degrees Celsius enters a counterflow heat exchanger with a mass flow rate 0.5 kilogram by seconds, and for air also they given you Cp enters at 30 degrees Celsius at the mass flow rate of 2.09 kilogram by seconds. In this, in the effective, in if the effectiveness of the heat exchanger is 0.8, the LMTD in degree Celsius. Here also they asked to find a LMTD. Sorry, I gave the answer here, right? Sorry. Okay. The answer is 10, but we can come to know about how the answer is comes. Okay. They have been given you two substances. One is water and another one is air. And for this, they have been given you two Cp values, water Cp value and air Cp value. For this, they are given you two temperatures, one is water temperature, another one is air temperature. For this, they have been given you two masses, one is water mass and another one is air mass. They have given also the effectiveness. Here comes the new word. They have been not yet seen this new word, and this new word is E, effectiveness symbol, which is 0.8. The LMTD, they asked to find the LMTD value, which is change in difference, del Tm in degree Celsius. The answer is actually 10, but let me see the answer, how the answer came. Yeah, they have been given you. They have to find out, they have told to find out the LMTD's value. For that, they are given you effectiveness value. By applying this effectiveness value, we have been given these three values, right? And Cp by C, Ch by C minimum, H is normal, so that mass into, yeah, uh, yes, 0.5 into 4.18 and 1 into 2.09. The value which comes minimum is the C minimum, which comes higher is the Ch. Just applying the value there and find out the value of temperature H2, that is 40 degrees Celsius. As I said, this and this will be always will be equal, So that applying this MH value is given, MC value is given, MCP H value is given, CCP value is given, and TH value is given. TH2 we have been found. This value have been found now. That is 40 degrees Celsius. These two values has been. This value is not given and this value is given, right? By applying that, we are going to find out the TC2 value. We are going to find out the TC value. Just cross multiply and find out the answer. And the answer will be 70 degrees Celsius. Okay, 70 degrees Celsius. So that by comparatively we see this, the answer will be 10 degrees Celsius. Okay, just applying the formula of LMTD. Here we have to apply the formula like this. Theta T1 minus theta T2 divided by ln of theta 1 divided by theta 2. If you apply the answer, we will get the value as 10. Got it? Yes. The answer is 10 degrees Celsius. Okay. Yes, this sum you yourself can try to do. In a condenser of a power plant, the steam condenser, which was asked in 2011, at a temperature of 60 degrees Celsius, the cooling water enters at 30 degrees Celsius and leaves at 45 degrees Celsius. The logarithmic mean temperature difference of a condenser is, yeah. Here also they given you three temperatures and they asked to find out LMTD, which is del Tm. Del Tm formula is nothing but general formula is capital T1 minus small t2 minus capital T2 minus small t1 divided by ln of T1 minus T2 divided by T2 minus T1, general formula. If you apply that, we can able to find the answer of the LMTD, but if you for that we should know about 4 temperatures, but here they given you only 3 temperatures, 60, 30 and 45. Okay, 60, 30 and 45. So that we can you can take the value of temperature 1 is equal to temperature 2, which is 60 degrees Celsius. Okay, and remaining as the same, the small t1 and small t2, small t1 and small t2, which is 30 and 45. Just apply in the formula. Which formula? T1 capital T1 minus small t2 minus capital T2 minus small t1 divided by ln of again this one T1 minus T2 divided by T2 minus T1, bracket close. Okay, this bracket close, this bracket close. Bracket should be correctly closed, if not the value will not be obtained. Okay, capital T1 and T2 60 60 minus T2 is 45 and T1 is 30 divided by ln of T1 minus T2 is T1 is 60 minus T2 is 45, answer is 15 divided by T2 minus T1 is 60 minus 30 is 30, 15 by 30, right? Yeah, 30 by 15, 30 minus 15. Answer is 21.6 degrees Celsius. Which answer? The answer B is the correct answer. Gentle. Yeah, you can able to see this. This is one step formula. If you apply the formula, finally the answer will be obtained. Okay. Okay. Yeah, the next question which was asked in 2002, which is one more question, is also a thing which is called as a simple question. By seeing itself, we can able to answer. The option is B. For the same inlet and outlet temperature of heat and cold fluid, the logarithmic is, yeah, greater from the counter flow heat exchanger than the parallel flow heat exchanger. This is the answer. Okay, what I'm saying is greater for counterflow heat exchanger than for parallel flow heat exchanger. LMTD value will be greater in counterflow, lesser in parallel flow. This is the answer for this. This is easy. Okay. Okay. Next question, which was asked in the year 2003, which is a 2 mark question, 2 mark question, and the formula here also they asked to find out the value for. Let me check. It is a counterflow heat exchanger. It is a counterflow heat exchanger. Okay, for hot, they are given you heat capacity, mass flow rate, and inlet temperature and outlet temperature. Okay. For cold, they given you heat capacity, they given you mass flow rate, they given you inlet temperature. Oh, here they ask to find neglect the heat transfer and the outlet temperature of the cold fluid is 0 degrees Celsius. They ask to find the outlet temperature of the cold fluid. Okay, they ask to find the outlet temperature of cold fluid, which is the T1. This is T1. Which is just general formula as you see in the previous. Just applying the values. This all the given topics. This and this. Okay, this one they asked to find. Okay, just apply the formula. Which formula? Single formula is there, the equal formula, which is equal m c p, the highest value minus t1 minus t2, capital T1 minus capital T2. That means mh cph, then again mc cpc, the highest given value is the outlet they asked to find. They asked to find the outlet temperature. Always the inlet temperature will be highest than or lower than the outlet temperature. So the given temperature is 20. So that we should find this value. Just apply all the given values m, cph, all the values apply. If you apply and if you apply, finally we will get the value of the outlet temperature, which is 32.5. Which is 32.5. Okay. So that what I said in previously, there's only two formulas, main formula. Use that formula and just apply the required values. Okay, the next question is asked in 2005, which is 2 mark question. In this question, they asked to find uh, which type of heat exchanger which is going for above the given temperatures we are going to design. Okay, here they are given you 4 temperatures and they are given you a del MTD. Okay, you see the temperature. 80, 50, 30 to 40, and this one is 20 Celsius. Okay, so that temperature one inlet, the hot oil is cooled from 80 degrees, highest temperature is 80 degrees Celsius, the lower temperature is 50, and the air temperature rises from 30 to 40 degree due to absorption of the heat. So the value LMTD value is 20 degrees Celsius. They ask you to find out the heat exchanger. For this, a simple thing is counterflow is the answer. I think so. If not, sorry. Not counterflow. The answer is cross flow. Okay. Okay. Yeah. Next question which was asked in 2007, which is an 2 mark question. In a counterflow, sorry, 1 mark question. In a counterflow heat exchanger, hot fluid enters at 60 degrees Celsius and leaves at 30 degrees Celsius. That means hot fluid high temperature 60 degree and the cold fluid leaves at 30 degrees Celsius. Okay. The mass flow rate of the fluid is 1 kilogram per second and the cold fluid is 5 kilo. The cold fluid is 5 kg per kilogram Kelvin. The logarithmic mean difference of these. They also here also they asked to find out the LMTD, which is known as del Tm, okay, same, what to say, the two capacities of the heat exchanger, the two capacities of the heat capacities have been given here as yeah, yes, both are same, so that's not a need actually there, and so that by applying the values, just we can note about the difference is 60 minus 30 is 30 degrees Celsius, so the value is 30, LMTD value is 30, okay. Yeah, next question is the 2008 question. By seeing this question, we can conclude this session. By next questions and all, we can see up the upcoming videos. Okay. The question is the logarithmic mean temperature difference of the counterflow heat exchange is 20 degrees Celsius. The cold fluid enters at 20 degrees Celsius and the hot fluid enters at 100 degrees Celsius. Mass flow rate of the cold fluid is twice the hot fluid. Specific heat at constant pressure of the hot fluid is twice the of the hot fluid. The specific heat of the constant of the hot fluid is twice of the hot fluid. Specific heat of the hot fluid is twice of the cold fluid. The exit temperature of the cold fluid is. They asked to find out the exit fluid of the cold temperature by using this formula. What I said, LMTD, the general formula. Okay. They have been given you LMTD in counterflow is 20 degrees Celsius, and means the entire of the hot fluid is 100 degrees Celsius. 100 minus 20 is 80. The answer is C. Simple. As previous, 60 minus 30 is 30. As still same here, the 100 minus 20 is 80. The answer is 80 degrees Celsius. Okay. Okay. We'll by before concluding session, just we can learn again the formula which is mainly important here is the LMTD formula. The LMTD formula is yeah. The LMTD formula is del T1 minus del T2 divided by ln of del T1 minus del T2, and another formula we should know is Q is equal to UA by del Tm. U is nothing but overall specific heat, which and A is area, and del Tm is change in temperature, which is LMTD. To find LMTD, we should know the three values, which is U, Q, U, Q, and A. If you apply this value, you can able to find a del Tm. If not, to find a del T1 minus del T2 divided by del T1 del T2, you can able to find out the answer for this also. So the general formulas will be like this. Here the del T1 and del T2. This is also a del T1 LMTD formula. This formula, the formula here, yes, the formula here is equal to the formula here. Okay, this both are same formula. Just you want to learn basic formula and apply the multiple sums, you can able to find out the answer for this. Okay, so that don't worry, heat transfer is a best paper to choose and learn all the topics. Previously I have been uploaded a video related to heat transfer. One video has been uploaded for general topics. Here I have been uploaded for specific topic for LMTD and NTU. Remaining sums will be solved in upcoming classes. If you have any doubts, you can ask in the queries. You should know the formulas first before going for solving the sums. The formula is mandatory. You should learn the formula. You should apply the formula twice or thrice in different sums, so that you can able to obtain the answer. Maximum it will be 1 mark question. It may also be 2 mark questions in some cases. So you can assume for 1 mark questions you can be able to get clear by using this simple concepts, the LMTD sums. Okay. Yeah, we'll go for this revision of these questions. First question is this. Answer will be applied just by applying the answer. You can able to get the answer 3.5 to 64. And another question is 21.83 meter square area. They have asked to find out the area. And for these questions and all, if you want to revise, you can revise it out. Okay. Okay. Uh, this all questions asked in previous gate mechanical papers. So this will be useful for all the mechanical students, and also for it will be useful for all the non-mechanical students like chemical productions, manufacturing, that type of branches. Okay. Thank you for joining us. We will see you on the next video. Thank you all. Thank you.